Yes. So friends, yesterday we stopped at this slide, right? So we have seen given number is in binary or octal or hexadecimal. So we have seen how to convert this into a decimal. Now in today's class, what we will do? We will do the reverse procedure. Like given number is in a decimal, how you are going to convert it to binary or octal or hexadecimal. It's a very simple process. So let's try to see how we can do this process. So first, let's say n is equal to 35. 35. Okay. And you want to convert this number into the binary. So you want to convert this n is equal to 35. So this is in decimal. If I did not mention the base, then by default, it is in decimal number system. So if I want to convert this 35 into base 2, so that is in binary. So let's see what is the procedure. Okay. So I want to convert into binary, right? So for you need to start divided by 2. So you need to start divided by 2. Divided by 2. Why? Because it is in binary, right? So I'll take 35. Now, when you divided this number by 2, so it goes 17 times. 2 17s are 34. And whatever the remainder that you need to write it here. So that remainder is 1. Next, repeat this process. So it goes 8 times. 2 8s are 16 and that remainder is 1. Okay. Now again repeat this process. 2 4s are 8. Okay. And the remainder is 0. So next. 2 2s are 4 and the remainder is 0. So next. 2 1s are 2 and the remainder is 0. Now if it is binary, so the possibilities are either 0, 1. So like how long you need to repeat this process? When this value is either 0 or 1. So whenever you get this value, either 1, so 0 or 1, so you can stop. So you can stop. Actually, you won't get 0, but whenever this is 1, we can stop. So after completion of this, so you need to write all these values in the reverse order. So write all these values in the reverse order. Reverse order. That is 1, then 0, then 0. So 0, then 1, and then 1. Now, this is in base 2. So which is in binary. So keeping this base is very important, friends. Otherwise, no one knows that it is in which number system. So if you did not keep the base now, then I can think of this is a 1 lakh. 1 lakh, 11 something. Therefore, okay. Keeping this base 2 is very important. Now, this is how given decimal number, we can convert this into a binary. So understood everyone? Very simple process. So start divided by 2, write all the reminders, write it in the reverse order. Okay. So now, next, let us take the another number. Let's say n is equal to 79. Okay. Now I want to convert this number into base 8. I want to convert this number into octal, that is in base 8. So let us see what is the process further. Okay, so if it is a octal, right? So what are all the possibilities, friends? 0 to 7, right? Possibilities are 0 to 7, right? Okay, so now I want to convert this into octal. So now what you need to do? So start divided by 8. Start divided by 8. Okay. Now take this number 79. Now start divided by 8. So 79, 8, how many times it will go? So tell me someone. It will go how many times? So 79, you will be getting 7 as the reminder. Right. Now again repeat this process. Okay. So 8. How many times it will go? 1 time it will go. So 8 1s are 8. What is the reminder? Reminder is 1. Now, do I need to repeat further? No, not required. So when to stop? So when you get any value between 0 to 7. So 0 to 7, if you found any value here, then you can stop. So ideally you won't be getting 0, but you can stop. Now, what is the final answer? So write this in the reverse order. So when you write this in the reverse order, what you are going to get it? So 1, 1, 7. And this is in which base? So this is very important. So mentioning the base is very important. So mentioning base is very important. So mentioning the base is very important. Otherwise, I will think that this is 117, normal 117, right? Okay. So similarly, next, if I take n is equal to, so let's say 114. Now I want to convert this number into base 16. Now we need to divide by what? We need to divide this number by what? Start dividing by 16. Very good. So because you want to convert this to base 16, right? Hexadecimal, right? So hence you need to divide this by base 16 and collect all the reminders. Okay. Now I'll take this 114. Okay. Now let me start dividing this value with 16. So 16 in 114, how many times it will go for the first? It goes 7 times. Very good. What is the reminder that you will be getting? It goes 7 times. So when you write it, 16. So how many times? 7 times, huh? So 16 7 jar is how much? 112, huh? Okay. 7, 2. So it goes 7 times and the remainder is 2. Now further, do I need to continue or can I stop? We can stop. We can stop. Why? Because here, if you found any value between 0 to 15, you can stop. Right? Okay. So now what is the final answer? The final answer will be, again, write this in the reverse order. So when you write this in the reverse order, 7, 2. Now this is in which base? This is in base 16. This is in base 16, that is hexadecimal. Okay. So now one thing that let's understand here, like this we have already done. Now I want to cross check whether the answer that I'm getting is right or wrong. So let us do how to do the cross checking. Okay. So let's verify cross checking. That is, convert this number back to decimal. Like for example, whatever this value is there, now I need to check, is it right or wrong? Okay. So how are you going to do this? So let us see. Now, this is in base 2. Now, do you know how to convert this into base 10? We have already seen yesterday. If I want to convert this into base 10, okay, first let us see it is in which number system. It is in base 2. How will you convert this into base 10? So very simple. You put all 2 powers. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, and 2 power 5. So now what you need to do? Simple. Multiply. 2 power 5 into 1. So you see this? 2 power 5 into 1 plus, is it required to write 0 into 2 power 4? That is anyhow 0. 0 into 2 power 3, that is anyhow 0. 0 into 2 square, which is anyhow 0. Plus 2 power 1 into 1. So this is 2 power 1 into 1. Plus 2 power 0. So 2 power 0 into 1. So cross checking this is. So finally, what is this? This is 32 plus, that is 2 plus this is 1. Now when you add it back, how much value that you are getting? So we are getting 35. So therefore, whatever we have did, that is correct. That is correct. Okay. Now let's do the same thing with others also. Okay. Now let us check. Whatever we got, it is right or wrong. It is right or wrong. Let us try to check. So we have got 117 now. Now let's convert this 117 into decimal. Let's convert this 117 into base 10, that is decimal. So how will you do? Since it is in base 8, right? So let's write 8 power 0. So let's write this is 8 power 1 and let's write this is 8 square. 8 square. So therefore now this is 8 square into 1 plus 8 power 1 into 1 plus 8 power 0. Okay, so into 7. Into 7. So now let's see what is this value. So 8 square is 64. 64 plus 8 power 1 into 1. So which is 8 plus 8 power 0 is 1. So 1 into 7, which is 7. Now what is this value? This is 15. 15 plus 64. So that is 79. Therefore, whatever we have done, that is also correct. That is also correct. Okay. Right. So now next. Now let us check whether this answer we got is right or wrong. Okay. So let me take this and let me verify this also. Okay. Now convert this value back to decimal. So how are you going to convert this back to decimal? Simply write this is 16 power 0 and this is 16 power 1. Okay. So now when you calculate this, so 16 power 1 into 7 plus 16 power 0 into 2 into 2. Okay, so what is 16 into 7? What is 16 into 7? 112, right? Plus 16 power 0, 1, 1 into 2, which is 2, which is 2. So now what is this value? So this value will be 140, sorry, 114. So 112 plus 2, that is 114. Now this is in base 10. So we got. So in a one slide, we have all the things that are present here. Okay, so clear everyone? Just in a single slide. So everything is present. So convert from decimal to different number systems, then decimal to different number systems. Okay, right. So let me give you the summary here. So for example, let's say here we have a decimal. So here we have decimal number system. So here we have a decimal number system that is base 10. Now you want to convert this decimal to base 2, base 8, whatever the base that is. For example, let's say if it is base 2 or it is base 8 or it is base 16. So what is the process for that? Like from decimal to going to different number systems. So what we need to do, friends, for this, we have to divide it by with that number. Okay, so divide it with that base. Divide with that base. And write reminders in the reverse order. So write reminders in reverse order. Reverse order. Okay. Now, if you want to convert this base to, okay, or base 8 or base 16, see the arrow mark, 2 decimal. If I want to do the reverse process, back to, okay. Then what to do, friends? For this, what to do? Write all the powers. Okay. So first write all the powers. So write all the powers. Okay. So for example, 2 power 0, 2 power 1, 2 square, 2 cube, and so on. So write all the powers, multiply, and then add. Multiply and add. That's it. Very simple. Okay. Now I'll give you one question. Now I hope this everyone understood this point. Now one more thing, friends. For example, if I say, if a number is in base 6, then what are all the digits that are available in that number system? Tell me, if a number is in base 6, then tell me what are all the digits that are available in that number system? Yes, 0 to 5. Very good. So that answer is 0 to 5. Okay, so that is 0 comma 1 comma 2 comma 3 comma 4 comma 5, like that. Right? Okay, so actually these three are popular, friends. So binary, octal, okay, hexadecimal. These three are actually popular. So these three are popular number systems. So these are actually popular number systems. Okay. Now I'll give you one question. Let's see some unpopular number systems. Like for example, so n is equal to let's say 30, 39. Now convert this number to base 5. Okay. Then tell me what is the answer for that. Okay. So wait. Instead of 13, let's take a little bigger number. So let us take 127. Okay. Now n is equal to 127. That is in base 10. Now can you convert this number to base 5? Tell me what is the answer. Now this time I'm going from decimal to, okay, binary. Not binary, it's a base 5. Okay. So first of all, you tell me, is n is equal to 127. It is in which base? This is in which base? You tell me. N is equal to 127 is in which base? Very good. So this is in base 10. So it is in base 10. Why it is in base 10? Because here I did not specify the base. Since I did not specify the base, so by default, it is in decimal. In decimal. Okay. Right. So now we are seeing a question based on unpopular number systems. That is in base 5. So what is the answer you are getting? 1002. Okay. So from decimal, see, from the decimal, if you want to go to any base, what you need to do? Divide with that base, write reminders in the reverse order. Okay, na? Now from decimal, I am going to base 5. So which means from base 10, actually I am going to base 5. So what I need to do? I need to divide and write the reminders. Okay. So now see the solution. This is 127. Now let me start divide this. So how many times it will go? 127. 25 times. 25 times it will go. So 525 are 125 and reminder that you will be getting as 2. Now repeat this process. 5 5 are 25 and the remainder is 0. So next, again, how many times it will go? So 5 1 are 5 and the remainder is 0. So here, when I can stop this, if the value is between 0 to 5, okay, so we can stop it. So we can stop. Now, after completion of, write this in the reverse order. So write all these values in the reverse order. So that is 1, 0, 0, 2. So you tell me, it is in which base? Yes, which is in base 5. Okay, so here it is 4 because it is in base 5 now. So 0 to 4. Okay, right. So now let us do the cross checking. So whenever you got na, so you can do the cross checking. Cross check. So how will you do the cross check? Convert back. So let us take whatever the value that you got, that is in base 5. Now convert this again back to 10. Convert this back to decimal. And if you are getting 127, then your answer is correct. Okay, how will you do the cross checking? So very easy. This time, what powers you need to write here? Tell me what powers we have to write. Because it is in base 5, so you need to write all the 5 powers. You need to write the 5 powers. So that is 5 power 0, then 5 power 1, then 5 square, then 5 cube. Okay. So now let's see. That is 5 cube, you need to multiply, okay, and you need to add. Next, 5 square into 0. This is anyhow, it will be 0. Next, this is 5 power 1 into 0. Next, 5 power 0 into 1 into 1. Okay, right. So 5 cube is 125 into 1. That is 125. See, whatever we have done, reverse of that we are doing. Nothing else here. So plus 0, plus 0, plus. So 5 power 0, 1. So this is 2 now. Okay. So here it is 2. So here it is 2. So which is 2. So now when you add it, okay, this is 127. So understood, friends? Everyone? So in the interview, they can ask popular number system questions or unpopular also. Okay, so they can ask either popular or unpopular also. Right? Okay, so now, so far whatever we have seen, friends, these are simple things only. Now, let's do some cross conversions. Let us do some cross conversion. Okay. What is meant by those cross conversion is, so see carefully here, see carefully. So the cross conversion, what is meant by cross conversion is, for example, n is equal to okay. Let's say this number is in base 2. Now I want to convert this number into base. Will you do base 10? Base 10 you can easily do, right? That is base 10 is easy. You just need to write all the 2 powers and you can do. But I want to convert this into base 8. Next, I want to convert same thing into base 16. Then how to do that? So that is called as a cross conversion. So I hope everyone understood what we are trying to solve. Okay. So now this is in base 2. We know how to convert into base 10. Because what we have seen actually, if you go to the previous slide, so if it is in base 10, how to convert to base 2, base 8, base 16 we have seen, or in any base. Similarly, if it is in a different base, we have seen how to convert it into base 10. Right? Now, what we will do now here is, since you want to convert this binary to octal. So first what we will see, so we will go to the next slide. So first let us see how to convert this into base 8, then we will see base 16. So now the question is, how will you convert this into base 8? Okay, so simple. What we will do here is, let us take the help of decimal number system. Because as a human, we can understand decimal, right? Okay, now first you take this, first whatever the given n is there, first convert this into decimal, then convert this decimal into octal. Okay, you know this process, right? So take maybe 5 minutes of time and solve and tell me what is the answer. So take some time and you solve and tell me the final answer. So I'm getting some, please don't do any calculation mistakes. So you can take time, no issue, but don't do any calculation mistakes. Okay. Yeah. 265. Okay. So everyone getting 265? Many students are giving 265 is the answer. Yeah, final answer in octal, tell me. Octal finally, how much is the answer? Okay. So good number of students are giving 265. Let me check what is the answer. So if you are solving, please solve. Those who are unable to solve, kindly see here. So solution. First, I will convert whatever this number n to base 10, I will show. And then we will take that, we will convert that to base 8. Okay. So let me take this number as it is. Now to convert this into base 10, we need to write all the 2 powers from the left side. So from the left side, we have to write all the 2 powers, 2 power 0 like that. So I will write directly those numbers. So 1, 2, 4, 8, 16, 32, 64, and then 128. Okay. I have written directly all the 2 powers. Right. So wherever 0, those you can ignore. Wherever we have 0, you can ignore. Because zeros anyhow, we won't count it. Wherever it is non-zero, you can add them. So that is 128 plus 32 plus 16 plus 4 plus 1. So when you add, what is this value? 5, 16, 21. So 21 means 53, 128. How much? 181. No, yeah, 181. Everyone getting 181? Okay. Yeah. So this is 181. This is 181. Right? This is in base 10 decimal. Now convert this back. Whatever this 181 is there, now convert this 181 back to octal. Right? How will you convert this to octal? Very easy. Start dividing with 8. So you take this as 181. Now start dividing with the 8. Okay. So how many times it will go in 8? 181, 22 times. Huh? Okay. So it will go 22 times. What is the remainder you are getting? 5 is the remainder. Very good. Next, repeat this process. 8 2 jar 16. 3 24 now, so it will not go. 8 2 jar 16. 16 plus 6 is the remainder. So we can stop right this. We can stop. We can stop. Okay. Now write all these values in the reverse order. Write all these values in the reverse order. If you write in the reverse order, that is 2, 6, 5. That is in base 8. Base 8. So understood, everyone? Okay. So let us do one small homework and then we will come back here. So let us do small one question, friends. So if I ask, for example, n is equal to 27, what is its binary value? If I ask n is equal to 27, so convert this into binary. So generally what you do, so you will take 27 and you will do divided by 2 and you write all the reminders, correct? This is how you are doing, right? Like when I ask a number and if I asked you to write it in the base 2, so you will be doing this process. But we can do directly, friends. We can do directly how it is. Write all the 2 powers from the left hand side. Write all the 2 powers from the left hand side. So please listen everyone this. So from the left side, when you write it, this is 1, that is 2, 4, 8, 16. Okay, now 32. So like that, it will go all the 2 powers because I want to convert this into base 2. So now you tell me one thing here, listen carefully and tell me one thing. So should we go till 16 or should we go till 32? Because when you do the reverse process, you are going to add all these things now. So we will go still 16. That is enough. 32 is not required. Why? Because 36 is bigger than 27. Na? So let us not take this. Let us go till here. Now let's write 27 is combination of 2 powers. That is 16 plus extra how much that is remaining? 16 plus extra how much is remaining? 11 is remaining, right? Okay. Now 11 is remaining. Now this 11, how can I write in terms of 2 powers? Can I write 8 plus 8 plus? How much is remaining? 3 is remaining. Now this 3, how I can write in terms of 2 powers? So 2 plus 1. So when you finally write this 27 as sum of 2 powers, that is 16 plus 8 plus 2 plus 1. Okay. Now wherever 16, so I will put 1 here. 8 is also there, I will put 1 here. 4 is also there, I will put 0 here. So 1 and 1. Wherever these are involved, I will put 1 and remaining places I will put 0. Now this is your answer, base 2. Now if you want, let us do the cross checking. So let us take 27. Now let's do the divided by 2. So how many times it will go? So it will go 13 times. The remainder is 1. Now how many times it will go? 2 6 jar 12. Remainder is 1. 2 3 jar 6. Remainder is 0. Then 1 jar 2 and the remainder is 1. Now when you write all this in the reverse order, what you are getting? So you are getting 1 1 0 1 1. Same thing only, na? Same thing only, na? Now let's do the reverse of this. Let us do the cross checking. So when you do the cross checking, 1 2 4. Now you will understand, see better. So now let's convert this back to decimal. So 16 plus 8 plus 2 plus 1. So don't you think this is same as what we have done? Actually, without doing this division, directly we are handling this problem, friends. Okay, those whoever got confused, so please listen again. Okay, I will explain one more time. So those whoever got confused, so please listen this. Please listen this. Okay. N is equal to 27. N is equal to 27. We want to convert this back to decimal. Okay, base 2. That is we want to do. Okay. Now see this. I hope everyone understood this step, how we have done. ये step सबको समझ में आया? This we have already seen. So when you write, what is the answer? 1 1 0 1 1. ये तो base 2 में है. Correct? I think this we everybody knows. No confusion here. Now I want to do the cross checking. अब मैं इसको cross checking करना है. Which means now I need to convert this to, this is the question. So this is the question. Okay. Now I want to convert this back to decimal. For that, what you are doing, you are writing all the 2 powers, right? So 2 power 0, okay, 2 power 1, 2 power 2. So 2 square, 2 cube, 2 power 4. This is what you are doing now. Understood? Okay. Now, when you convert this back, what we will do? So you are writing 16 plus, wherever 0 that you can ignore, wherever 1 that you can take. Okay, 16 plus 8 plus 2 plus 1. So which is 27. Now what I am telling is, instead of doing this division, so what I'm trying to say is, okay, so you take this as it is. First you write directly all the 2 powers. 1, 2, 4, 8, 16. Now don't take 32 because it is maximum 27 only na. So don't go till 27. तो अब मैं क्या करूंगा, ये जो 27 है ना, ये sum of 2 powers में लिख दूंगा. ठीक है? So that is 16 plus leftover value 11 है. So 11 is 8 plus 3. 3 means 2 plus 1. ठीक है? So wherever 16 I will put 1. 8 is there, yes, I will put 1. Wherever 4 is not there, 0. So 2 is there, I will put 1. So 1 is there, I will put 1. So this is the only same thing. Na? Instead of doing this division, directly we are writing. That is what I am trying to say. Understood? Now you might be get a question. Sir, what if that number is a bigger number? If the number is 723, तो इसको भी same process कर सकता है. For this also we will do. Okay. But yeah, it depends which method you want to go, you can go. But ultimately getting the correct answer is very important. Okay. So now, for example, now I will give you a question. Now I will give you the question. Now tell me, what is the binary for the 7? What is the binary value for the 7? Quickly tell me. Now don't do that process. Division process don't do, because it is a smaller number. Na? 7 is a smaller number, right? Don't do the division. So taking 7, okay, don't do this. Instead of directly you take, so 1, 2, 4. Should we need to take 8? Do we need to take 8? No, 8 is not required because maximum 7 only. Okay. So 4 plus 2 plus 6, 6 plus 1, 7. So you can directly write 111 base 2. Understood? Like that. Now let's say n is equal to 13. N is equal to 13. Tell me directly what is the binary? What is the binary for this? So you simply write 1, 2, 4, 8. So 13 means 8 plus 4, 12. 12 plus 1, 13. So you put 0 here. So 1, 1, 0, 1 base 2. Okay. So next, n is equal to 14 or n is equal to 9. Tell me what is this? So write like this: 1, 2, 4, 8. So 8 plus 1, 9. Remaining you put 0. Base 2. So number is a small, you can do directly, friends. If the number is a smaller number, you can do directly. If it is a bigger, better go with the division. Okay. So maybe I will write it here. So note, if number is small, then write directly. Okay. So otherwise, go with the division. Okay. So hope this is clear. Right. So now let's see another question. Let's see another question. So tell me, what is the decimal for this? What is the decimal for this? Reverse of that. So simple. Write all the 2 powers. So 1, 2, 4, 8. So zeros you ignore. Once you add it, 4 plus 2, 6. 6. Okay. Zeros we have to ignore. Wherever ones are there, we need to add. Same process only. Now next. So tell me, what is this in decimal? So it is a base 2. So 8 plus 4 plus 1. Why you are not taking 2? Because it is 0 anyhow, it will be 0 only. So this is 13. Okay. So next. Tell me what is the answer for this? No, I changed this to 1. It is not 7. What is this answer? I changed this to 1. One 35. Okay. So simple. You write from the left side. 1, 2, 4, 8, 16, 32, 64, 128. So you need to add all the 1 terms. All the 1 terms you need to add. That is 128 plus 4 plus 2 plus 1. So this is anyhow 7. 7 plus 128. That is 135. Okay. So it is clear now, friends. Everyone? Clear? So whichever method applicable, you can go with that. But ultimately, getting the correct answer is important. So getting the correct answer is important. Okay. Right. So now let's go back. Let's go back and see where we have stopped here. Yes. So we have seen this question and we want to convert this to octal. Then what we have did? So we first converted this into a decimal, then converted this back to octal. So now I will take this slide and let me explain here. Okay, but instead of doing this process, we have one very simple process, friends. So let me tell you what is that simple process. Okay, so what we did it here, we first converted to decimal, then we converted to octal. Without converting to decimal, we can solve this question. We have to get answer as 265. Okay, let me see how it will be. So what we have to do is, since we want to convert number n, okay, to octal, right? Octal, na? So octal is nothing but base 8. Octal is nothing but base 8, right? So base 8 is 2 power 3. Everyone agree? Base 8 is 2 power 3, right? So from the left side, sorry, right to left, starting from right to left, group 3 bits, 3 bits, and write their decimal value. Okay, so which means, so see this carefully, friends. I want to convert this number, okay, to octal. Since I want to convert this to octal, so from right to left, so which means in this manner. So right to left. So right to left, because I want to convert this to octal, I will group the 3 bits. So 3 bits I will group, because here nothing, na? So you can put 0, no problem. So you can put the 0 or you can leave also, no issue. Even if you leave it also, no problem. So group 3 bits. Now when you group 3 bits, what is this decimal value? What is its decimal value? 1, 2, 4. So 4 plus 1, that is 5. What is this decimal value? 1, 2, 4. 4 plus 2, 6. What is this decimal value? 1, 2. So 2. So finally answer is 265. Base 8. So understood? Very simple process. Very simple process. You no need to convert back to decimal. Directly we can solve this. It's easy, right? Compared to the previous method. It is easy, right? Where you no need to convert back to decimal. Okay. Directly you can group 3 and you can do like this. Now next, let's see another question. Okay. So do you want to solve this question? Okay. So everyone take pen and paper and tell me what is this value into octal number system. So write it very carefully on the paper and do properly. Don't do any mistakes. Okay. So I'm getting some answers. Did everyone getting this answer? Somebody is getting this, but somebody is saying this answer also. Somebody is saying this. Okay, let me check what is the answer. So I'll copy this one more time and I will paste it. So we want to convert this number back to octal. So we want to convert this to octal, friends. So since it is a octal, so how many bits from right to left I need to group? Octal means base 8. So 8 is nothing but 2 power 3. So 3 bits you need to group. So group 3 bits. Group 3 bits from right to left. From right to left, which means like this. Okay. Now 3 bits if I group, this is one group. Then, so you should be very careful. Then this is another group. 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 And this is another group. So if you don't have anything, you can put 0 also, but it will be no issue. Okay. Now what is the decimal for this? 6. I am writing directly because you are already good with that. Okay. Now what is the decimal for this? 0. Now what is the decimal for this? 3. Now what is the decimal for this? 1. What is the decimal for this? 3. What is the decimal for this? 3. What is the decimal for this? Again, this is 3. So when you write all this, 3, 3, 3, 1, 3, 0, 6. 6. So this is the final answer in base 8. So 3, 3, 3, 1, 3, 0, 6. And this is the answer. So whoever getting this, that is the correct answer. So please don't do the calculation mistakes. That's the only I want to say. Now, same thing, if you want to do convert base 2 to decimal, right? And again, convert this back to octal. Don't you think it is a lot of QS? It's going to take a lot of headache, right? Somewhere if you done mistake means that is gone. Somewhere 0 and 1, if you miss by chance, if you replace, then completely it is gone. Okay, na? Everyone understood, friends? Are you enjoying these kind of things? Come on. Are you enjoying these things? If you are really following the class means you will enjoy like anything. And it is one of my favorite topic. Number system actually one of my favorite topic. Okay, good. So now let's same question. What we will do is now let's convert this back to hexadecimal. Instead of octal, I will write hexadecimal. That is base 16. Base 16. Now what we need to do, friends? Same thing. Okay. See here, I'll copy and paste this. Since we want to convert this number to octal to hexadecimal, HD means hexadecimal. So it is base 16. So base 16 is 2 power 4. Okay. So now what we need to do, starting from right to left, group 4 bits. Group 4 bits and write their decimal value. Okay. Now can you do same thing and tell me what is the answer you are getting? So tell me the answer that you are getting in the hexadecimal. So in hexadecimal, what are all the possible values that we have, friends? Hexadecimal. I know some people will do some mistakes. In hexadecimal, what we have? We have 0 to 9 and we have A to F. We have A to F. Okay. So A, B, C, D, E, F. So A is 10, B is 11, 12, 13, 14, 15. So let us now group 4. So from the right to left. So you should start from right and you should go left. And you need to group 4. So this is one group. This is another group. This is another group. This is another group. Okay. Like that 4 groups, we 4 bits. Let's group. Now what is this value? This is 6. What about this? This is 12. What about this? This is 2. What about this? So 8 to 4 to 1. 8 plus 2, 10. 10 plus 1, 11. What about this? 8 to 4. 12. 12 plus 1, 13. 13. But should we write 13 or should we write D? Tell me. Should we write 13 or should we write D? We have to write D because it is in hexadecimal. If you are writing 13, then gone. Then that answer is utter flop. Okay, so this should be D. Next, if you are writing 11 means, then that is flop. So 11 means B. So 2 is 2 only, no change. 12 is C. So 6 is 6 only. And this is the final answer. That is in base 16. Okay, so clear, everyone? Clear? Now you should play like anything. Number system concepts, you should play like anything. Okay, good. So now next. So this you can take it as a homework. Maybe you can take this question as a homework and you can solve it later. Okay, now come on, tell me what is the answer for this. Now this is in base 16. They are asking you to convert it into binary. That is base 2. So what you will be doing? First, you will be converting it to base 10. Then you will be converting it into base 2. Do we do this? Do we do this process? No, this is utter flop. Directly, right? 4 bits, you write, and you can close this. Right? Okay, whatever you do, but tell me what is the answer for that. Okay, I will ask, I'll little complicate this question. You convert this to octal. Now solve this. Convert this into octal number system. Just one small change here. Instead of 9, you put 5. Instead of 9, you put 5. Now you solve this question. No, my question is octal. Finally, you tell me answer in octal. Okay, I'm getting one answer. So I'll write it here. This is one answer I'm getting. Then I'm getting another answer also. I'll write it like this. 2055275. Okay. Many students are giving this answer. 2055275. This is slightly complicated question compared to previous questions. But उतना complicated भी नहीं है. You can solve it. Okay, so I'll explain the solution. So people who are trying, you please try, and I'll tell you the solution for this. So let me take this, will be helpful. Okay, see one method is first you can convert this to base 10. Then from base 10, you can convert that to base 8. That is one method. But I'm not interested in that. I'm not interested in that method. So which method I'm interested? I'll do direct method. So see the solution. See, this is the hexadecimal, right? So what I will do? 8, 5, A, B, T. And this is in hexadecimal. Now in hexadecimal, every character or every digit that we have, we can represent it in 4 bits. So how will you represent 8 using 4 bits? 1000. I am writing directly. Similarly, how will you represent 5 in hexadecimal 4 bits? Normally 5 is 101, correct? But I want to represent it in 4 bits. So you need to add 0 to this. You need to add 0 to the left. Why you need to add 0 to the left? Because 4 bits are required not to represent that number. So hence you need to add left 0 to that. Why you have to add left to 0 it? Right side can't I add 0? If I add 0 to the right side, is there any problem? Tell me, friends. Right side if I add, is there any problem? Yes, of course there is a problem. So for example, let's say, okay, so if Anjali texted to Lokesh saying that, hey baby, please do a recharge of 399 rupees. Okay, then there is no problem. Even if Anjali sends like this, 03999 also, there is no problem. What if she texted like this, hey baby, please do a recharge of like this, then Lokesh will suicide. भाई रिचार्ज के लिए कौन इतना इतना कौन पे करेगा 399 reasonable somehow Lokesh will do but what if she put a 0 to the right side, its value is going to change, right? So therefore, okay, so you can add 0 to the right left side, there is no problem, but right side you cannot add it. But as I said, if it is in a hexadecimal, you need to group 4 bits na. So hence 5 also we need to do 0 and 101. Okay. What about A? A is how much? A is 10. So 10 you can do directly 1010. This is no problem. What about B? B is 11. So 11 is, if you are doubt, you write like this 8421. 822, 10, 10 plus 1, 11. So 1011. Like that you can do directly 1011. Okay. What about D? D is 4, 13. So 13 means 8, 4, 1 required. So 1, 1, 0, 1. Okay. 1, 1, 0, 1. Now I converted this into base 2 directly. Without doing hangama, directly I converted. Now this you need to convert back to octal. Now how you know octal? From right to left, group 3 bits. So which means first you group these 3. Okay. Then next you group these 3. Okay. Next you group these 3. Don't do the mistakes. Okay. Then next you group these 3. Next you group these 3. Okay. Next you group these 3. When you group this is 5, 7. This is 2. This is 5. This is also 5. This is 0. This is 2. So final answer is 2, 0, 5, 5, 2, 7, 5. This is the correct answer. So whoever got this answer, very good. So understood, friends, everyone, how we have done? Okay, small 0, 1, if you change, then answer is gone. So you should be very careful. एक बार 0, 1 हो गया ना, then that is completely gone. So you should be very careful when you are solving these kind of questions. Okay, so now, okay, will you solve this question? This is straightforward only, na? This is straightforward. You can take it as a homework. And let me check. This also you can take it as a homework. And you solve. Okay, I will give you one question. Okay. So shall we take one gate question? Shall I show one gate question? Let me show one question. Just give me a minute. I will add that question. So let me share my screen. Come on, you take this question. So more than one option is correct. So more than one option is correct. Okay. So here radix means base. Some people will call radix. Okay. So radix means base. Now come on. You can work out and tell me what is the correct answer for this. So write all the correct options. Write all the correct options. ABD. Okay. Everyone getting ABD? ABD आ रहा है सबको? Nice. Then that is correct. Yeah, ABD is the correct. So let me explain the solution here. So the question is, which of the following is or there can be more than one option correct equal to 224 in radix 5. Okay, मतलब एक जो number है that is in base 5. So first of all, you tell me, is it a valid representation or invalid representation? Is it a valid or invalid? 224 in base 5. It is a valid one. So it is a valid. Because all the numbers are in the range of 0 to 4 only. So it is valid. Now, first let us check option A. Okay, 64 in radix 10. So let us check that. So how will you convert 224 base 5 to base 10? How will you convert, friends? Simple, write all the 5 powers. So 5 power 1, 5 square, same process that we have saw. Sorry, 5 power 0, start from 5 power 0, units place now. So 5 power 0, 5 power 1 and 5 square. So 5 square is 25, 25 into 2 plus 5 into 2 plus 5 power 0 is 1. So 1 into 4. So what is this value? 50 plus 10, 60, 60 plus 4, 64. And this is in base 10. So 64 in base 10. Okay, option A is correct. Now they are checking, is it 100 in radix 8? So which means they are saying 100 in radix 8. So you can easily convert this into base 10 and you can verify, right? If you are getting 64 means that is correct. So let us check. So this is 8 power 0. This is 8 power 1. This is 8 square. So when you convert this back to decimal, so it will be 64 plus 0 plus 0. So that is 64 in base 10. So yes, it is matching, right? Therefore, option B is also correct. Let me check option C. Option C, let us check. If this has to be correct, then so you take this is 50 and that is in base 16. Now again convert this back to base 10. Base 10. So what is this value, friends, when you convert this back to base 10? So this is 16 power 0 and this is 16 power 1. So now when you convert back, this is 16 power 1 into 5 plus this is 1 into 0. So this is how much? 16 5 are 80. 80 which is in base 10. But is it equal to 64 in base 10? No, right? So option C is incorrect. Okay. Now let me check the last option. Let me check the last option. 121 in radix 7. So 121 in radix 7. Now when you convert this back to base 10, you should supposed to get 64, which means then it is equal. Now how will you convert this back? Very easy. So you write this is 7 power 0. So 7 power 1 and 7 square. So 7 square is 49. So 49 into 1 plus 7 power 1, that is 7 into 2 plus 7 power 0 is 1. So 1 into 1. How much this is? This is 14. This is 1. 15 plus 49. So this is 64, right? 64. That is in base 10. So therefore, this is also matching. So option D is also correct. So what are the finally correct answers? So A comma, B comma, D. These are the correct answers. Right? So everyone understood, friends, what we are doing? Simple only, convert everything back to decimal. Things will be super easy. Okay. So convert things to decimal, then it will be super easy. You can easily answer these kind of questions. Okay. So what is the time? 12:46. Huh? Okay. So one small topic is there that I want to discuss, that is ASCII. Okay. So should we take this tomorrow? I think there is one assignment is there, na, based on this. Okay, let us take this tomorrow. It will be too much if I discuss now. So this just, it requires 5 to 10 minutes only. 5 to 10 minutes. Okay. So I will take tomorrow this. Though it is 5 to 10 minutes, but over ho jayega. Okay. I'll discuss tomorrow. No issues. Okay. So tomorrow starting of the class, I will discuss this ASCII and then I will start the class. Okay. So I think one problem is there, na, assignment related to ASCII. So that you can solve tomorrow. That you can solve tomorrow. So, but till today, whatever we have discussed, so this completes the number system topic, friends. So this completes the number system topic. So I hope you all got a good understanding. So there are some students who still face some issue. So I would request again, you go back to the video and wherever your doubt is there, you please listen to that video and solve more and more problems so that this topic should be in hand. Right? Cool. Yeah, somebody asking, sir, assignment. Yeah, you can do it on pen and paper and take the photo and you can upload that. Okay, so whenever you are submitting the assignments, so you can do it on the paper and you can submit. Right? Okay, so let me stop the recording and then I'll clear your doubts.